Okay, this is 8.3.9, and everything we need when we hit the icon, this is for a mean, and they will give us all the results. But let's first answer the question. Okay, the claim is that they're from a population having a mean less than 4.00. So it's a left tail test. That's the alternative hypothesis. That's where the claim goes. So the null is that it's equal. Well, less than, but in this case equal. So it would be B, letter B. See, there's the claim in the alternative. Mu is less than 4. Okay, the test statistic. So what I do is I click on the I, and you can see there's the results. And when we were doing proportions, they just gave it to us as part of the question. Now we have to open up another window, but there it is. So the test statistic, it's a T because we don't know sigma. That's the difference. In a proportion, it's always a Z, but for a mean, it could be either a T or a Z. The difference is if you don't know sigma, you use T. Well, there's no evidence here that we knew sigma. We're using S. So if we're using S, it's a T. So the test statistic, the 2 decimal places, is minus 3.50. So negative 3.50. The p-value is 0.0005. 3 decimal places, it'd be 0. I'm just going to put 0. They like my answer. But wasn't enough to round it up to 0.001, so it's just 0. So state the final conclusion. Since the p-value is low, let's see, what was the alpha was 0.05. We're much less than 0.05. We're way in the left-hand tail because the t is a negative test statistic. So we're way in the left-hand tail. We're supporting the claim. So we're rejecting H naught. There is sufficient evidence to support the claim because the claim is in the alternative. That's what if we're rejecting the null, we're supporting the alternative. Okay. So let's try another one of these with data. See, but all these have an I in them, so they're all similar. Okay, here's one where there's summary statistics. This is 8.3.15. So N is 83. X bar is 3.44, and S is 0.62, alpha is 0.05. And the claim is that student course evaluations have a mean equal to 3.5. So mu equals 3.0. That's the null. The null goes, or the claim goes into the null because it says equals. So the alternative is not equals. So it's a 2-tailed test. It's number C, or letter C. Determine the test statistic. So now I'm going to go to StatCrunch. I think I copied down all the relevant. Oops, close that. All right. So when I get to StatCrunch, I got stat. I go to T-stat because I don't know. So it's one sample and it's summary. I don't have data, so I use summary. So the mean is X bar, 3.44. Now you can see we're less than the claim. The claim was 3.5. Standard deviation 0.62. But are we far enough away given this sample size of 83? And then mu was 3.5. And the alternative is not equal. So you follow what I did? I put 3.5 here and not equal for the alternative. You see, for this book, the null is always equal. Some use less than or equal, greater than or equal, or strictly equal. But there's always equal. So that if it's a one-tailed test, they don't bother with it. So the p-value is rather high. The test statistic, the t-test, is minus 0.8817, and the p-value is 0.3805. There's only one chance in 3 of being this remote. We're fair. We're close enough to 3.5. We're not going to reject. Here it comes. Okay, so the test statistic T was minus 0.88 to 2 decimal places. So negative 0.88. Check answer. Good to go. P-value was rounded 3 decimal places, was 0.381. Obviously, it's not low. It certainly isn't less than 0.05 or 0.025. So we're not going to reject. So failed to reject. There is sufficient evidence to conclude that the original claim that the mean of the population of student course evaluations is equal to 3.5 is correct. I'm not sure what they're driving at here. Sometimes these are screwball. We're not rejecting, so that's correct. Okay. Here's what they want to do it backwards. There's not sufficient evidence. See, now they're doing it in a negative. On an earlier one, I did it in a negative. They didn't like it. Now they want a negative. So I hope you follow this because it is confusing. Okay, so enough of that one. I'm glad they gave me a second chance. Okay, let's find one with data, and we'll end it there. That last one was 13. I got to make a note there. All right, and then see if we can find one with data. There we go. So this is 21. 8, 3, 21. All right, so it's very similar to the last one. It's just that instead of using summary, I'm going to use data. So first of all, just below are the lead concentrations in different traditional medicines. So we're going to use a 10% significance level to test the claim that the lead concentration is less than 18 milligrams. So the claim is that mu is less than 18 milligrams per gram, micrograms per gram. All right, so that's the alternative. So the null is that mu is equal to 18. So it has to be D. Right? All right. So now determine the test statistic. So now I'm going to open up StatCrunch. Oh, maybe I should have closed the previous StatCrunch. Yeah, I'm going to close that previous one. So now when I go to show you what I'm doing, my lab. See, the difference for me is it says my StatLab data instead of StatCrunch. It's StatCrunch, but it's, in other words, there's data. We move the data from the problem right into StatCrunch. So I'm going to do stat. Well, once again, it's a t-stat because we're going to use the sample standard deviation. So it's one sample with data. So I highlight VAR1, and I do the same thing. Down here, I tell it that mu is equal to 18. That's the null. So the alternative was less than 18. And compute. So the t-stat is minus 2.0587. The p-value is 0.0348. And that's less than 0.10. So how about that? So we're going to reject. But that's okay. We're going to support the claim. That's the whole point of this. We want to support the claim. That's what they would like, if you think about it. You see, they're claiming that it's less than 18. And so if we reject the null, that means we're going to support the claim, which is less than 18. So test statistic was minus 2.06. The p-value and the readout we got was 0.035. And that's less than 0.1. So we're going to reject. So there is sufficient evidence. See, we're supporting the claim, so that's why it's in the positive. And the claim is that there was less than 18 milligrams, so we're supporting the claim. So there you go. So 3 different ways to do hypothesis testing with means. Remember now, if the only difference is if they do in the problem somewhere state what sigma is for the population, then you use sigma instead of S. Even if you have raw data or you have summary stats for a sample, if they tell you that there's a value for sigma, then you would use sigma and you would use a z-test for the mean instead of a t-test. It's the only difference. Okie dokie. Dr. K out.